Hello, and welcome to today's webinar, What's New in Data Science and AI? My name is Liz Herrera, and I am the Director of Advanced Analytics with LPA Software Solutions. Before we get started, I want to introduce LPA to those folks on the line who are not yet familiar with us. LPA Software Solutions is an analytics consulting firm that has been in business since 2001. We have over 500 clients across a variety of industries, including healthcare, hospitality, insurance, finance, manufacturing, government, education, retail, energy, and banking, plus more. And you'll see here on the slide 3 really well-known and industry-leading partners who we work with. In addition to implementing and training our partners' technology solutions, we also provide consultative services to our clients on everything from analytics strategy, advanced and predictive analytics, business intelligence, data management and governance, as well as financial planning analytics. And our team members are tenured with an average of 10 plus years experience in the field implementing analytics solutions. We are truly committed to customer enablement and self-sufficiency. We definitely want to help folks learn how to fish. So with that intro to who we are, I want to thank you again for joining us and move into the content for today's webinar. So we're going to talk about how to distinguish the hype from the reality of data science and AI and discuss some real trends that we're seeing in the field with our clients, how folks are getting prepared for and testing out these approaches. And then we'll wrap things up by providing some recommendations for how you can get started on your own data science and AI journey. So what is all the hype about anyway? I think everyone tuning in has probably been inundated with commercials and articles and even news programs that contain the latest buzzwords related to data science, machine learning, and AI. With any, quote, new technology or methodology, it's sometimes difficult to parse out what is just buzz versus what is real. In this case, the reality is that the underpinnings for data science, machine learning, and AI have been around for a really long time. And I'll give you a personal story here. I remember being in grad school and researching machine learning, and I was shocked to learn, that it had begun in the 50s with statistical approaches and kind of peaked in the 70s and then tapered off for several decades until, the current resurgence. So that was certainly a lesson for myself in doing due diligence and some research and being aware that really what is new is old. So the three things that I think that are different today around data science, machine learning, and AI are, one, the sheer volume and variety of data that's available today is really prime for these methodologies. The second thing is that the technology that we have is certainly better than it used to be, and it's also democratizing these kind of advanced methods in ways that really weren't possible before. And thirdly, I think that organizations are really ready to get hands-on and test out advanced analytics, more so than they ever were before. Instead of just talking about these kinds of analytics, they're really ready to get started doing it. So I found that organizations have really moved up the analytics maturity curve. So what I would like to do next is to really unpack these three terms a bit, just to level set so that we're using common terminology. All right, let's start with data science. And I found this great infographic from Simplilearn that I thought did a great job of explaining data science. So if you start at the bottom, middle, and left here, the real beginning point for data science is the business problem or business question. Why is something happening? And you might actually be that person who's either asking why, or you're being asked why is something happening? If we can't get the answer from a report or a dashboard, this is a good candidate for some advanced analytics. So once you've identified that business problem, we want to look at what data we have available. And oftentimes we start with internal data, but there has been a real proliferation in external data sets that are available and that can be brought into an analysis. So certainly consider, combining both your internal plus some external data. Then we move to data cleansing and transformation. That comes next. And this is always a key step. And often, frankly, it's the most time consuming in data science. Next comes some descriptive or summary statistics or analysis to understand data elements, distributions, maybe do some feature generation. And then we can finally apply some modeling. In this case, the example here shows some of the newer iterations of algorithms like decision trees, neural networks, as well as, we can really use some traditional statistical methods as well to build models. When we get some results, we share those with stakeholders, and after some maybe feedback and iteration, we can finally deploy and maintain our final models. So that really, in a nutshell, this whole kind of visual here is the data science process. It's cyclic and dynamic, rinse and repeat. But I think two components that the picture is missing are first governance. So having a process in place for managing, codifying, and eventually operationalizing the data workflows in your models, as well as secondly, collaboration. In all likelihood, you're not going to have just a single data scientist on an island, but rather you're likely to have a team of folks with different skill sets around data management, analytics, as well as the business who need to share assets as well as ideas. Now, moving on to machine learning, I liked this graphic to help depict how machine learning can be found at the intersection of methodology, and that's, data science, data mining, computer science programming, as well as the elements of data, features, and algorithms. Machine learning really applies analytics and algorithmic methods to data in order to predict something. That's really all it is. And we can use this approach with data that has been either well-defined and categorized, and that's called supervised learning, or we can use it with unlabeled data where we really let the algorithm identify patterns and importance, and that's unsupervised learning. Some of the methods you might have heard before are classification, regression, clustering, association, dimension reduction. Those are all really some of the main machine learning methods that are used today. Finally, we have AI, artificial or augmented intelligence. And this is a great quote from the renowned computer scientist Larry Tesler, and he worked for Xerox, Apple, Amazon, and many other companies. Artificial intelligence is whatever hasn't been done yet. And I share this a bit tongue-in-cheek. This is where really I think we need to separate out all the hype from the reality. AI has been a catch-all for a lot of new ideas and innovation and techniques, but more recently, I think we've seen some real advances in technology that combine capabilities like machine learning, natural language processing, deep learning, and others in ways that are accessible outside of academia, and of course, Jeopardy for those Watson fans out there. So some real examples of where AI is at play today. If you've ever used a smart home device, for example, to ask what the weather is going to be tomorrow, that's an example of AI. Or if you've interacted with a virtual assistant when you dial into a call center for some support, more often than not, you're going to be interacting with some AI on that first level. Also, fraud detection on your credit card transactions. If you've noticed that your bank is pretty good in real time at picking up a fraudulent transaction and calling you right away, most likely in the background there was some AI running to do that detection. Also, when you're shopping online, dynamic pricing, the prices change at different points in the day or based on certain conditions, or if you've left things in your cart for a bit, maybe you get a different price. So that dynamic pricing that you experience is most likely the result of AI in the background. Also, pattern and image recognition, that's really big today to support doctors, maybe in healthcare, or for quality control on an assembly line. So those are some examples of how AI is already being used, and they're really a lot more opportunities, I think, to uncover some new uses for AI. So what are some of the new trends that we're seeing in the field, relative to data science and AI? What are our clients doing? So there are really a handful of things that I'm seeing in terms of real capabilities and trends in data science, the real versus the hype. One of the first things and most important things that I've seen, recently in terms of a major trend is infrastructure modernization. So our clients, what I'm finding, are interested in ways that they can reduce costs and increase flexibility in their infrastructure. And really the way that they're doing this is to explore things like containers or Kubernetes, microservices. So instead of standing out these huge environments, with a lot to maintain, instead they're looking at maybe cloud or hybrid deployments with containerized applications that can spin up as needed. Maybe some microservices, you don't need necessarily the whole application, just certain components. Certainly seeing that as a way to enable them to test and iterate quickly through some new ideas, new analytics, while still having the ability ultimately to scale at the end of the day, because that's important too. You don't want to get stuck, just with a small sized environment and not be able to scale up. I'm also seeing an increased interest in using integrated tool sets for data science. So these are unified platforms that can provide a place to park your data, to run applications, and to collaborate across data and modeling assets. Another key element of these platforms is having the ability to manage and deploy models. This has always been one of the most challenging aspects of data science, but I've been really impressed at how much the technology has advanced to support quick deployment while still having robust ways to interrogate and manage models. Two more trends that I'm seeing related to AI specifically. I have more and more clients who are ready to explore their unstructured data, really unprecedented, and they're interested specifically in applying natural language processing to text. I think everyone has probably heard of NLP at this point, so there's definitely interest in applying that to extract some meaning, and then hopefully being able to operationalize that insight into some kind of end applications or to inform predictive models, so as part of a workflow for modeling when combining with their structured data. So that's certainly a big trend I'm seeing right now is, I think folks have a good handle on their structured data, but they're very interested in exploring what they can do with their unstructured data. I'm also seeing an increase in the need for and interest in automation. So that comes up all the time. How do we do things better through automation? As well as dynamic learning. So iterating more quickly and having models that learn dynamically. And finally, also the use of virtual assistants in some outward-facing applications. I think what's exciting about this trend is that it relates to deployment. I already mentioned this. Deployment's always the hardest thing that you're going to do related to data science and AI, and you really have to think about that up front. One of the ways you can deploy is giving some thought to user experience. So that side of data science and machine learning. So, some of these new modalities are really a great way to consider outward-facing consumption and deployment. So far, we've talked about what data science and AI are and some of the trends that we're seeing out in the field. And I haven't really talked about technology specifically up until now, but from a technology standpoint, there are lots of options out there to support data science and AI work, which is fantastic. There's a lot of value in being able to explore both open source and proprietary technologies. As an IBM Platinum Business Partner, I do want to mention the IBM AI Portfolio as something that I would highly recommend checking out. IBM provides a whole ecosystem with capabilities. And you'll see here on this slide, starting on the bottom, you have your infrastructure layer. So having a cloud or hybrid cloud environment that has containerized views and the ability to layer on APIs and different applications is really great. As well as in the middle layer having some data science capabilities. So we have everything from Watson Studio, which combines open source technology with the IBM SPSS technologies. You have machine learning capabilities that are pretty robust here, including some pretty neat neural networks, if you get a chance to check that out. We also have Watson Knowledge Catalog, so being able to apply some of the NLP to your unstructured data and gain some meaning from that. And then finally, Watson OpenScale, which allows you to manage your models. And also, this is really cool, gives you transparency into the AI models. So that's something that has been a real challenge in the past. And I've just been so impressed with OpenScale, the ability for the platform to actually show you how your model is performing, to dynamically tweak it to make it better, and to give you transparency into not just the model overall, but individual level predictions. So if you need to go back from an audit perspective or just to your stakeholders and tell them how something was predicted, you can do that. It's very transparent. So that definitely worth checking out. And finally, the top layer with the Watson application services, there are all sorts of both APIs. There's just a whole catalog of APIs that have been developed based on the Watson technology. And there are some specific solutions that are out there as well that are certainly worth checking out, including Watson Discovery and Watson Explorer, again, for your unstructured data to be able to, crawl or mine some unstructured data and gain some insight into concepts and sentiment. Maybe the Watson Virtual Assistant that can help you with any of those outward-facing applications. It's not just a chatbot. It's dynamic. It learns. And it certainly is worth looking into, as well as I mentioned, the APIs. So I hope at this point that you're asking yourself, how do I get started on my own data science and AI journey? And we have a recommended approach for this. How do you get ready for data science and AI? And there are 4 real components that we would recommend here. The first is to assess where your organization is in terms of data readiness. We often use maturity curves like the one displayed on the bottom left of the screen here to help determine where an organization is in terms of their use of data and analytics, as well as culture. What we typically find is that our clients have a solid footprint in the lower left of the curve there. So the cost reduction, modernization, doing operations, BI and data warehousing, they're pretty solid in that. And they're certainly making strides moving into the self-service analytics column as well. And at this point, they found that their business is missing out by not pursuing advanced analytics. So that's really a kind of a key indicator that you might be ready to test out data science and AI. If you feel like you've gotten to the point where you've got a good handle on your data and reporting and maybe doing some self-serve, but you're leaving something on the table by not doing more. So this is really the prime time to do a visioning exercise. So what are the questions you would ask, or what are the business problems you want to tackle that are more forward-looking that you haven't addressed so far? So something that would increase revenue or decrease spend, improve your customer satisfaction, or help you compete to be a market leader, and ultimately, hopefully, to transform your business. So what are those kind of big questions that you should be asking or addressing? So identify a target use case to explore, something that will give you insight into what's possible, what could add value to your organization. Part of the target selection process is to determine what data you have available for analysis. And you want to prioritize a use case that you have at least some data available. Now, it's an important point. I often hear that folks don't feel like they can get started with data science because they're not sure if they have the right data. And this is the great thing about data science, is that by nature, it's exploratory. It's designed to help you explore the data that you do have and iterate quickly to determine if it will provide some kind of insight. When we do find that there are data gaps, that's actually okay. That's not a deal breaker. It helps us determine what other data we need to or should be collecting and incorporating into our analytics efforts. So don't let that stop you if you feel like, oh, we don't have all of our data or it's not all warehoused. It shouldn't slow you down. You can always get started with data science and AI, given the data that you do have available. So once you have a target use case to test, the next step is to align your internal resources. And the key players here are the folks who understand and can access your data, as well as individuals with a good understanding of the use case you'll be testing. So definitely think ahead about who are the people in your organization or on your team who you think would be able to access the data, who might be able to help translate some of the business problems. Those are really the key players to getting going on this process. And finally, plan for a proof of technology, or if you want to call this a proof of concept or an MVP, any one of those, some kind of activity to actually engage with data science and AI technology. You want to use your data against your target use case. And this is a great opportunity to see what actually is possible, and it's pretty low stakes. What I found is that doing these POTs, these proofs of technology, gives folks confidence that they can do this kind of work. And oftentimes, it's just the beginning of really a transformative effort for the business. So as you begin your data science and AI journey, we'd be happy to help you at any point along the way. We can assist with doing a readiness check for either data and skills, with prioritizing a target use case, and with supporting a proof point. Please do not hesitate to reach out to discuss how we can help you as you explore data science and AI. If you have any questions, at this point, please enter them into the chat window, or you can email us at the address posted on the screen, and we'll be happy to follow up with you. And with that, I'd like to thank you for your time and for tuning in today. All right, let's take a couple of questions. So the first question, what is deep learning? So I think I mentioned deep learning maybe briefly earlier, but thanks for calling that out, because that is one of those buzzwords, right? I think we've all heard deep learning out there quite a bit. So what does that actually mean? So deep learning is actually part of machine learning, and it's a part of machine learning where you're designing complex models. So usually this means neural networks. So you may want to use deep learning models if you're looking, for example, to translate speech to text in real time, or if you wanted to use some of that visual recognition I mentioned, so with images or objects. That's really, those are two really good use cases or areas where you might want to explore some deep learning. But at the end of the day, ultimately, it's just another machine learning methodology. All right, so great question, thank you. Let's take another one. What if we don't have any data scientists on staff? And this is also a really good question, and one I hear all the time. I hear this quite often with clients who worry that they don't have data scientists or statisticians in-house, or there are no PhDs. You don't need to have hired a team of data scientists to get started with advanced analytics. What I found is that if you have people who deeply understand your data as well as your business, if you have those people, then you can get started with data science and AI. Part of what you might want to evaluate as you test it out is whether you need to bring in new skills. So this is a great way to help you identify, do you have a gap area that you need to fill? And it may be a gap where you can enable your internal team members with these skills, or you might want to look externally at ways to gain those skills as well. But yeah, it's not a deal breaker if you don't have a data scientist. I mentioned earlier, these methods have been around for a long time, and with the technology being what it is today, it's so accessible that you can really have a variety of skills in-house and still be successful leveraging data science and AI. And as I mentioned, if you find that you have a gap area, that might, if this is a strategic direction for you, then you can look outside potentially to bringing those skills in-house, to acquiring those. The other thing, obviously, as an analytics firm and a partner, we would certainly be happy to help you with that. We often work with clients to get them started, to do training, or to do even a small project just to get you going. I have some clients where we've done initial projects and then provided support over time, but they've built their internal capacity to do data science. So definitely, if you want to, please reach out to us. We'd be happy to chat more about that. Okay. So let's do one more. What are the biggest barriers to being successful with AI? So great question. Definitely kind of a loaded question there. I think there are a few things that come to mind for me that can really be barriers or slow things down when it comes to being successful with AI. First thing on the infrastructure side, a common issue that we found is if your data is siloed, maybe it's difficult to access, they're disparate, maybe you have a lack of governance. I hear that quite often. So what does that mean? If your data are siloed or ungoverned, it doesn't mean that you can't get started. It just means that you need to be aware that if AI is going to be part of that strategic direction moving forward, then that's something you're going to have to address, that you will have to address infrastructure as part of a final solution. And I found that it is very common to have infrastructure issues like that, that you need to at least be prepared to address, acknowledging it and being prepared to address that if you want to move forward with AI. So that's one thing. The second thing I think is a barrier is technology, which might sound odd to you, but because there's really a lot of tools out there, but I think that's the problem. It's really easy to get overwhelmed with options or end up with a lot of disparate tool sets that just don't work together. So that actually is pretty frequent. What I found in our clients is that they've tried a lot of different things, and no one thing works all the time, and it's a real challenge to integrate the different technologies. More often than not, what I see is a good option is having different technology to fit the skills of your team. I think that's really critical, is identifying what are the skills within your team. Most often what I find this meaning is having some kind of open source technology for the folks on your team who are more expert and who want to do coding. So maybe they want to do Python or the scripting, or they want to use notebooks, or they want to actually code their own algorithms. So having an option for those folks, but also having an option that's more user-friendly for more of your analyst types. I mentioned before when we were looking at that data science infographic that you probably don't have a single person on an island doing this work. You probably have a handful of people with different skill sets. Not all of them are going to be those hardcore coders. So you also want to have some kind of option for the folks who are maybe more business analysts that is maybe more graphical, more user-friendly. And the key here, I think, is to think about integration and scalability. So any of the technology that you're interested in, you have to think about integrating it, right? Because at the end of the day, you don't want folks working in disparate systems and not being able to either collaborate and share what they're doing, or to get stuck when it comes to deployment. I mentioned deployment a few times. It's really a critical piece of the puzzle here. You can build a bunch of models, but if you're not prepared to deploy them, you're going to be stuck. There's going to be no value there. And you don't want to set up your folks for failure by not having an environment and technology tools that allow them to collaborate and ultimately to jointly develop something that can be deployed. And on that note, I think the last key barrier that I've come across in terms of being successful with AI is culture. I alluded to this earlier when we were talking about that maturity curve, but really it is critical to have support and sponsorship internally. Ideally this is at the executive level, but definitely at least at a level where you're going to have support for AI initiatives. Often the cultural aspect involves awareness building. People hear AI and think it's all a black box and it can't be trusted, and that doesn't have to be the case. You can certainly make that part of your requirements as you're exploring AI, is to insist on transparency in the process. I think that's a really critical piece. You want to have explainability and transparency in what you're doing so that people trust in the process and they can get on board. So I know that was a really long response to your question, but hopefully that helped to answer the question. So for anyone whose question I didn't get to, we'll follow up directly with you. If you have any questions later, please don't hesitate to reach out or visit lpa.com and we will be in touch. And with that, I'll thank you again for joining us and have a great day.